Okay. Okay, thanks for joining us in November, just November's LDNA, Limerick.net Azure User Group. I'm delighted to welcome Onder, cloud architect at Avanade and Microsoft Azure MVP for quite a few years now. I'm not going to butcher an introduction because, as Onder told us earlier, he knows himself very well. So we'll let him introduce himself. Without further ado, Onder, thanks for joining us.
Yeah, thank you, Carl. Thank you, Sagaldeep, and then thank you, invite me. Yes, my name is Önder there. I'm the new for your group. This is the first actually presentation. Today, I would like to cover the Terraform with Azure. Actually, this will be a introduction actually because we will not go so much deep dive. Firstly, I would like to give some, the theoretical information about what's the Terraform, when we're gonna use the Terraform, what's the difference, the Terraform instead of, the ARM templates or Bicep. And I'm gonna give some information about the configuration, some of the variables and stuff like that. And after that, I will do some the basic demos. I hope if it will be, the helpful for you guys, and maybe if you would like to, maybe in the second or the third session, we're gonna go some maybe the advanced, the Terraforms. We can cover the more modules and functions or logics or something like that. So as I said, yes, my name is Önder there. I'm the cloud architect in Avanade, Ireland. I'm also the Microsoft Azure MVP since 2013. I have Microsoft Certified Trainer certification since 2009. I'm not actively trainer right now, but before in my background, I did so many, the training for companies or maybe the individual, the training I did so much, and I have almost more than 20 years, the industry experience. I have a couple of Azure certification plus HashiCorp certification, which is the Terraform. I newly got this one maybe 6 months ago, version 2 or 3. I don't remember the newest one, but the newest one I got it. If you just follow this session, maybe you can get this this HashiCorp exam also. It will not so much hard. I can assure you, so you can easily complete. You just need to be to follow some of the maybe theoretical things, and also maybe a little bit of practice. So what we're gonna cover today, today actually we're gonna look at what's the Terraform, and then we're gonna look at the Terraform instead of ARM templates or Bicep, why we should use the Terraform, and then we're gonna look at the Terraform configuration, providers, resources, and state, which is the most important one, I believe so. And then we will do some, the basic demos. I will write some basic codes, and we're gonna deploy these codes to the our Azure environment. So let's start with what's the Terraform. Actually, Terraform is built by at the HashiCorp companies. The HashiCorp use their own language, which is the HashiCorp language, and the Terraform is a tool for building, changing, and versioning the infrastructure, the safely, and I can say maybe the efficiently. Terraform is maybe the most popular infrastructure as a code in our the industry, I can say like this. Terraform also can help with multi-cloud by having a one workflow for all clouds, we can say, and that the infrastructure Terraform managed can be hosted on public clouds like the Azure, like a AWS, like a Google Cloud, or it could be on-prem in your private clouds, such as the OpenStack or VMware vSphere, or it could be I don't know, maybe the CloudStack. So the Terraform infrastructure actually integrations also allow you to manage software and services, including database like a MySQL, or source control system like a GitHub, or maybe the configuration management tools like Chef and so on. Of course, there are over 100, maybe the more, publicly available, the infrastructure integration. You can find this these providers also in the Terraform websites, and it's a very powerful actually being able to describe all of your infrastructure in the Terraform code. So even if you are only sorry sorry even if you are only using a one cloud, Terraform, I can say, is a great options and can make it easier leverage, the multi-cloud in the future. So why we should use the Terraform? Because we can use the ARM template or the Bicep in our Azure environment. Actually, choosing between the Terraform ARM templates and the Bicep for managing Microsoft Azure environment depends on various factors, including your maybe your team's expertise could be, or maybe the complexity for your infrastructure and maybe for your specific requirement. But if you need to make a list of advantage of Terraform, I think we can say firstly Terraform is an open source and cloud agnostic tool. So meaning, as I said before, it supports not just the Azure, it supports also the multi-cloud and your on-premise environment. So this particularly useful if you are managing or planning to manage a multi-cloud environment. So, and also I will mention this one in the later, of course. Terraform maintains a state file. This is really important, and which provides a clear view how the actual infrastructure maps your configuration. So this can be extremely helpful for the large scale deployments and complex, of course, the architecture. So, and also Terraform has a large and really active community. So this means a wide, the variety of modules and providers you can find there, and these ones are available, and you can easily get this, the providers and the modules, and you can add your project easily. And Terraform use, as I mentioned before, HashiCorp configuration language, and this language is really easy to readable and writable by humans. So when you look at the code, so you can, if you don't have any background, software development background like me, so you can easily understand when you look at just the Terraform code. So it's not hard to build the basic or maybe the complex environment. And also Terraform, we can say, integrates really great with the various CI/CD pipelines, and has you can use these CI/CD pipelines for your testing, for your planning, for your prod, for UAT environment. And also, I think we can say Terraform, like ARM and the Bicep infrastructure as a code, it's a declarative. So meaning you define actually the desired state of your infrastructure, and your Terraform tool figures out how to achieve that states. Of course, so actually, however, it's important to consider the other side of maybe the arms and the Bicep, because Terraform, yes, is great, and you can easily maybe delete your environment with a Terraform code, or build your environment with a Terraform code. But the ARM templates and the Bicep are Azure native tools. So sometimes when at least the newest resources on the Azure, sometimes Terraform cannot support the quickly. So sometimes we need to use the Bicep and the ARM templates for the latest the resources. So we can confess about this one. And in some case, the maybe your team is more familiar, the using the ARM templates and the Bicep because of the Azure native tooling. Sometimes it could be a challenging use of Terraform. But I can say if you are using a really large complex environment, not just the one provider, could be a multi-cloud, or could be an on-premise or hybrid cloud. So it can be useful, Terraform. But as I said, there's some cons, this can be especially the latest resources. You know, for example, if the Microsoft release a new resource, so it could be hard to find the the Terraform codes. So let's look at the Terraform configurations. So actually, as I said before, HashiCorp configuration language, which is HCL, it was designed to be human readable. So, and of course, easy to editable. So depending on your background, actually, you can be easily pick up the HCL with a minimal, the effort. So now let's look at the slides, and we can see the the syntax, HCL syntax in there. First of all, in the below sides, you can see the comments in here. In the Terraform, we have two type of commands column. So multi-line and a single line. Multi-line commands are enclosed in a slash asterisk characters, and single line commands with after the numbering number sign. And also we have the configuration blocks. Configuration blocks start with a keyword, by the way. For example, it indicates the type of configuration. It could be a provider, it could be a variable, or it could be a resource, or it could be an output, or something like that. And also followed by one or more strings, and then map enclose the braces. Usually there is one string after the keyword, and it indicates a name. For example, the name of the provider or the name of the variable. So if you can see, this resource has a FGT, something like that. It's a name. For resource, there are two strings, as I said. The first is the type of the resource, and the second is the name of the Terraform. And what we can say, and of course, we're gonna look at the providers and the resource in the next slides. So when we use the providers, actually, the providers, actually the Terraform codes start with the provider. The provider wraps the create, read, update, and delete API calls normally, and these calls, of course, needed to manage your infrastructure, your resources. So it's easily to tell what provider a resource use, because the type of the resource always begin with the name. It's a provider. For example, this because we're gonna look at the Microsoft Azure, this resource provider start with the Azure RM. So your configuration actually can use a many provider as you need. So the Terraform doesn't ship with any built-in providers. So instead, it's use a plugin architecture to download the provider plugins required by your configuration. By the way, if you don't find any providers in the Terraform websites, or the Terraform has not built this provider, itself, you can, by the way, if you know, of course, the Golang language, you can write your own, the provider. But mostly popular ones, the vendors has their own providers. So you can find this one in the Microsoft the websites, and also, but not Microsoft websites, sorry, Terraform websites. You can find in there, and you can download and you can use your the providers. But we're gonna use, of course, the Microsoft Azure, which is the Azure RM. So you can use also the version in here. So version, you can start with the equal, or you can use also the less than, or the greater than. You can use this versioning in there for your provider section. But as I said, the Terraform codes always start with the providers. Of course, include the providers, we can define another blocks, like a status, like I don't know, authentication. But in the basic, your providers just cover what's your provider, and also what's the provider version. And after, of course, we need to define the resources. Actually, a resource is in Terraform is really simply, because as I mentioned before, the Terraform resources can be anything, from cloud virtual machines to the SQL database or web app or DNS records, whatever you want. Actually, whatever you want to build in your environment, you just need to define this resource in your Terraform code, and after that you can easily deploy. Of course, every resource has their own attributes and arguments. For example, in here you can see the Azure Windows virtual machines we're gonna create, and this resource has VM name, but this VM name, of course, the Terraform resource name, not the VM's name. Okay, so we just need to, if we need to call this resource in another block, so we just need to use this name. But of course, VM name will be VM-demo. Location will be Central US, size standard. By the way, this white space is not important. So the Terraform never look at the how many white space you using. You just use the Terraform FMT commands. It's automatically align everything. You don't need to worry about this the space. So you just look at the in this slides. You can see we have the resource in here, and of course every resource has own attributes and arguments. So in our demo, I'm gonna show how we can create a resource and their attributes and also the arguments. And finally, I think for me most important one, the state management. State management actually is the feature that allows you to manage, store, and retrieve the current state of resource managed by your Terraform deployments. So the Terraform state is a representation of the current state of your infrastructure resources. So this is how Terraform keeps track of resources managed by the Terraform project. So this includes the resource attributes such as resource name, resource IDs, and any metadata associated with the deployed resources. And also Terraform state is a stored in a state file using a .tf state file extension created and maintained by Terraform. As I said, maintained by Terraform because state file is not edited manually. So this is important. You cannot edit the state file. If you edit the state file, you can be ensure about that you will destroy your current environment. So this state file is important because it allows the Terraform to monitor the resources it manage and is used to determine the action needed to bring resource back to the desired state when the Terraform configuration is changed. And you can store this state file on your local system, or totally we recommend to use the remote state file, because when you use this Terraform code in your team, so you cannot share it. Actually, the local state file is not easy to share, so you can use the remote state files. So, and if you add this your configuration infrastructure configuration file, which is the Terraform one, in your CI/CD pipeline, so it's not easy to use the local state file, and also it's not secure because everyone can access and get the your resource IDs, your resource name, IP address, and other the important information. So let's put this one in a remotely. Remotely means you can put this state file in your Azure Blob storage, or if you would like to build, some AWS environment, you can put this one S3, the bucket, AWS S3 bucket, whatever you want. So, which means you can put your state file in your cloud storage. So, when you put this state file in your cloud storage, you don't need to so much worry about also the security and the management, of course. So let's look at, I think, a little bit demo. So how we can build the basic, the Azure resources with our Terraform code. So let me stop the sharing and open my Visual Studio Code. Give me a second. So before going demo, is there any question?
Neil was asking, I responded in the chat, but to give you a
Mhm.
chance to respond as well, would there be any reason to use an older version of a provider? So I was talking about how enterprises quite commonly pin versions because there can be breaking changes between provider versions, but
And that makes sense, Carl, as what you said there. I didn't think of it from a pipelines point of view. Obviously, if you've got pipelines already there, and then somebody introduces something new in the provider, it could well bust something. So that makes sense.
And to say that one of the enterprises I work with, or have worked with, sorry, in the past, they pinned a provider version to a quite old version and never went back to visit it. So if you're going to entertain pinning provider versions, have something in your process that goes back and make sure that you're regularly updating these things as well. Yes, it will mean that you have to go and rewrite some code and retest some stuff if there are breaking changes, but that way you won't get too far behind. I'd suggest you do it at least once every 6 months if you're pinning provider versions, just to make sure that everything works with the more recent versions, you know. Sorry, Under, go ahead.
Perfect. Thank you. Thank you for your answer. So you see my screen, right now? So actually, maybe before we start the demo, so maybe I need to tell how we can run your Terraform in your local environment. You just need to go to Terraform websites and download the Terraform binary, and then you can save this binary something somewhere in your computer. So for example, I put this one C tools folders. It's just the exe Terraform, and then you just need to open system path. You just need to show, your environment variable here. And after that, you can run your Terraform code in your CMD, the command prompt. You can easily run your Terraform in your command prompt. So I'm going to use the VS Code for the build the Terraform. So let's create a first our Terraform file. It will be, I said open. I just need to say main.tf. Are all, by the way, I have Copilot. If you don't have, and if you are using the VS Code, I totally recommend to use the GitHub Copilot. It's incredible help. You just start the typing and it's automatically complete, the every codes. So it's really, really great. So let's go back to Terraform. So our Terraform files extension will be a TF, and you can define your the Terraform configuration in your main TF file. So you can give the name whatever you want, but the extension must be of course the TF. So let's start with of course firstly the provider. So let's say the recur version, and then recur providers. You see, it's automatically come. We not use the AWS. We are use the Azure RM. And let's say, okay. And let's add the one more provider here, which is the Azure RM and the features. So we can now start to define our resources. So firstly, let's create a resource group. So our resource will be a resource group. Provider is Azure RM. And then we need to define the resource name. Yes, Copilot I'm using here, Neil. Because of that,
awesome, thanks. I missed about 30 seconds there.
Yeah.
That's great. I've never actually seen it in the flesh being used, so it's really good. Thank you.
Yeah, it's really great. Not just for the Terraform, by the way. Every code, it's really helpful.
Awesome.
So Azure RM resource group we're gonna create, and then resource group name. For example, let's say VNet RG. This is not the resource group name. This is actually Terraform resource group name. So we're gonna call this name later. So you will see. So our resource group name will be, for example, let's say demo, let's say RG demo 01, and the location will be North Europe. And then let's continue to create a one resource, one virtual network and one subnet. As I said, just the virtual network, and it's typed the virtual network. You see, Copilot just listening me. So resource will be Azure Virtual Network. So let's delete and type ourselves. So Azure Virtual Network, and the name is VNet. Okay, and we just need to close this one. And the name could be VNet Demo 01. Okay. So the location we need to type. So by the way, I can write the location like this. Like I can say the North Europe, or I can say Azure RM resource group. Name is VNet RG dot location. And then let's create where we're gonna create this VNet and which resource group we're gonna use. So resource group name. So I can say this resource group name, I can copy from here. It's okay, but when I run this code, it will give an error because Terraform is not run by order, you know. So it can be run this command randomly. So it can be try to firstly create the VNets, but before sorry, when try to create the VNets, and if there is no the resource group, which the name is RG demo 01, so it can be failed. So I don't want to use this one, and I would like to use same again here, Azure RM resource group VNet RG.ray. So I take here. Sorry. So the resource group, and the final one, address space. So let's say 20.0.0.0/16. So this will be our VNet. And then second one, let's create a resource Azure RM subnet. It's automatically right. The subnet name, subnet demo 01, and the resource group will be the same. Azure RM resource group VNet RG dot name this one. And the virtual network, Azure RM virtual network dot VNet here. If to give this name VNet 01, so you have to put this one 01 also. So, and the name, of course, we're going to use this name. Address prefix, let's say 20.0.0.0/24. And let's close it. Okay, let's save it and let's open the terminal. So I just need to log in my my tenant. And I have multiple subscription in here. So I just need to choose my subscription. Give me a second. Here, copy this is my subscription. And then I can run my Terraform code. Firstly, I need to initialize my code. So my code is Terraform initialize. I'm running. You can see it's a built up folder in here under my main folder. So where is this one? I can show you. Desktop demo01. You can see my folder in here, demo01. I just create this file, main.tf, but is when I create the initialize, it automatically create a provider. You can see it's a downloaded. And I create also the HCL log file. So, and after that, I can run the plan. You don't need to run this one. You can directly apply your code, but let's try the plan firstly. And let's look at our environment before we deploy. So it will say normally three resources will be created. One the resource group, and one VNet, and one subnet. So it will take maybe 1 minute. As you can see, it's automatically create a TF state file, which is locally, because I didn't mention any. I'm going to use the the remote state file. So because of that, it's automatically create a local state file. As I said before, it's not editable. It's totally the edit and created by your Terraform HashiCorp. So you can see in here. Come on. Any question in here?
Not yet.
Yes, the plan is complete. You can see the resources has a plus, which means it will be create. So it will be create first the resource group, and then will be create virtual network, and then will be create the subnet. So you can see the plan. 3 resource will be added. So now we can run Terraform apply. So which means it will be now deployed to my Azure environment. By the way, let's create another one. And we're waiting this one. So let's say file, open folder, desktop, demo02. So I will just copy this one in here. So, but this time I would like to use new file, which is variable .tf. So I don't want to put the name or I don't know values in main TF. I would like to call this values from variable file. So give me a second.
We have a question in the chat there, Under, when you have a second.
Yeah, give me a second. So what's the it's get if your resources already exist, of course, you will have an error. It says it will says your your resource is already in there. But if you change your state file manually, maybe you can destroy your the resource. So because the state file, if they have if it's has no information about your resource in there, so you can destroy. Or if your state file has the information about your resource, so you can get an error. But sometimes in some specific scenario, you need to define your the existing resources in your code also. So when you run the Terraform apply, there is a specific commands in there. You can say, this resource ID in there, this resource ID in there. So if you say like this, you will not get any error, or I don't know, some accident deletion or something like that. But there is no rewrite, I can say. So it's what it says in here. We just need to say yes, and it will start to deployment. So we have the main TF in here, right? And let's say, firstly, variable dot rg name. First, let's say location and type string default North Europe, and then variable, let's say resource group name, and let's say demo 02. Let's save this one, and let's go back to main TF, and let's delete this guy and call var.rgname. So because we defined this resource group name in this variable file, and this variable file variable's name is rgname, so I can call this one in my main TF, which is the var.rgname. And same for the location, because we define already in variables files. So we can say the var.location. So why we need to use actually the variables? Because this could be not just the one environment, so this could be the prod environment, UAT environment, I don't know, staging, non-prod, or something like that. You will have maybe many different environments. So you can use these variables for your the different environments. So it will be really useful. So I totally recommend to use the variable files when you build your Terraform. So you can use these variables for your every resources, by the way. For example, in here, we can say variable VNet name type string and default VNet2. So let's say var.vnet name. So by the way, it's completed. So let's look at, I have a portal here. This is my Azure environment. So let's go to my subscription. And resource group in here. Yeah, you see the RG demo 01 and my VNet in here, and also my subnet in here. So it's automatically built by Terraform. So let's go back to my, where is this demo 2? Yeah. Let's change this, guys. Let's say 10 dot. And let's call this one more variable subnet name. And in here, let's call var dot subnet name. Before, if you remember, I deploy demo1 with the local state file. So let's use remote state file for our demo02. So I have, if I go back to my portal, I have a storage account in here. And this storage account has a container, remote state. And in here, let's delete this guy. In here, I have one empty state file. This guy. You can see the size 0. So I'm going to use this state file for my demo. You can define your remote state file in your main TF, or if you want, you can use, give me a second, a different file like a backend.tf, and you can type your backend configuration in here. So what is the resource group of the storage accounts? So let's copy resource group, this guy, and my storage account name, this one, and my container name, this guy. And what is my state file name? This guy. And maybe I can add also my subscription ID and tenant ID. So let's save all and let's go terminal and run the Terraform in it again. And then run Terraform apply. I don't want to use the plan now. So the name is different. Yep. You see, it's already writing something. And we will not have any local state file in here. This is the demo 1. We have local state file. If we go to demo 2, there's no NTF state file. By the way, in the variable, of course, I can't show this one, but maybe in the advanced Terraform session we can show. We just not just the string one we can use. You know, we can use the list, we can use the map. If you would like to create, for example, multiple resource in a one Terraform, you know, the code. So you can use, for example, map or the list. You know, you can create a for each command in your main TF, and you can write a, you know, you can create a multiple resource in a one time. So let's say yes in here. So it's automatically will be great. Or give a second, maybe we have still time, so maybe I can. So maybe let's go to demo 3 and let's go create quickly main.tf. So let's copy the Terraform here. So, and then as type let's go variables.tf. And in the variables, of course, we have location, and this location so North Europe, and then variable rg name. So rg name, let's say resource group reg storage, and then variable storage account type. This time, let's say not string, let's say map string. And then default, for example, under storage 001, and this will be, let's say, locally redundant storage. And I'm going to create a second one, let's say geo-redundant storage. And I'm going to create the third one, let's say, how we call read access geo-redundant storage, right? Okay. So I'm going to create a 3 resource, which will be a storage accounts. And then this storage accounts name will be this one, and this will be a availability type. Okay, so let's go back to our main TF. And firstly, of course, we need to create our resource group. Resource. So the resource group RG, the name var.rg name, and the location var.location. So now I can create a resource group name Azure RM storage account, and let's say storage 01. And of course, I need to use the for each, because it could be a 5 storage accounts or 4 storage accounts, whatever I define in the variables. So it will be var storage accounts, and the name I'm gonna call from each key. Account tier could be a standard, and then yeah, account replication type would be a each value. Resource group will be Azure resource group dot name, and then location will be a dot location. So what it does it like?
You
Sorry.
defined access tier, not account tier.
Yeah, account here. Okay. So if you look at the name in here, I said each dot key. So the key, these guys, under storage 1, under storage 2, and under storage 3. And also account replication type will be each dot value. And the value, which is locally redundant, geo-redundant, and read access geo-redundant. So we can run also this one. Let's check. Terraform init. What does it like? Where I will not strings. And then let's run the Terraform apply here. By the way, when it's running, this is complete, which is the reboots. Sorry, this is 1. Where is 2? I close 2, I think. Give a second. So what it says, of course. So where is this one? North Europe. Correct, right? Because I write North Europe. Save all. Let's apply again. So what is my situation in here? It doesn't like. Okay, still running. Sorry. So let's say yes. Storage accounts creating. Source group in here. So let's check.
Yeah, the Azure portal is definitely slow to realize something's going on.
Come on. Yeah. So 3 storage accounts, and 1 is locally redundant, and the second one is geo-redundant, and the third one is read access geo-redundant storage. So which means in variables, not you don't need to use use a string or boolean. You can use the map, and also you can use the list. You can use the variables for your different environment. You can create, for example, prot variable. You can create, the non-prot VAT variables files, and you can use the state file locally, and you can use the remote state file. Depends of your project. So, any questions? I think I complete my demos and presentation. I hope it's useful
Awesome.
for you guys.
Great session. Thank you,
Awesome,
Under.
yeah.
Anybody, any
Really enjoyed that. It
questions?
was great.
Any questions in the chat? Neil, do you often get your hands on the tools these days, or are you well away from that?
No, I mean, I'm quite far away from the tools in terms of time. It's nice to stick my head into bits and pieces like this to bring me back into the real world again, Cara, especially seeing I'm not managing cloud stuff, but hopefully that won't continue forever.
Well, if it does, then there's a certain orange team down the road from you can do with delivery management experience. All right, well, Honor,
Perfect.
great session. Thanks for joining us.
Thank you so much.
This
Definitely invite
session, if you would like to watch it again, or if you'd like to share it with anybody, will be available on YouTube in the next few days. Other than that, we'll see you probably this time next month for our final session of the year. So looking forward to that, and we'll tweet and post on LinkedIn and stuff and let you know when and what that session is going to be when we know. So have a good evening and have a good remainder of the week.
Thank you.
Thanks
Thank
for
you,
joining
everyone.
us.
Yeah,
Thanks,
thank you so
everybody.
much. Thank you so much. Yeah.
Bye.
Bye-bye.
Bye-bye.